Topic 3-5, Part 2. You can also use the property for dividing powers with the same base to examine and justify another special case. Simplify the expression x cubed divided by x to the fifth. Well, remember that x cubed is 3/8. 8 times 8 times 8. Divided by 8 to the fifth is 8 times 8 times 8 times 8 times 8, 5/8. So, looking at this problem here, I've brought it on down. Now, remember, when you are dividing, you can subtract exponents. That's one way to look at it. Or you can write it out long ways like I've done and cross out. An 8 in the numerator and an 8 in the denominator, cross out. Here, here, and here. So how many 8s are left? Well, there's 2 8s left with 1 on top. If everything leaves the numerator, it leaves you a 1. So with me expanding it out, you see my final answer is 1 divided by 8 times 8, which is 8 squared. So that would be our final answer there. 1 divided by 8 squared. Now remember, you can also just subtract the exponents like I've done in this example. If you have 8 cubed divided by 8 to the fifth, subtract exponents. 3 minus 5. Well, if you punch in your calculator, 3 minus 5, you get -2. Now, you never leave me a negative exponent. What you're going to do with any term that's raised to the negative power, you will move it to the denominator and it becomes +2. It changes the negative exponent from -2 to +2. And again, if everything leaves the numerator, you must leave me a 1. So again, your final answer is 1 divided by 8 squared. So with this problem, I've worked it 2 different ways. The first way, I expanded it out. 8 times 8 times 8, 3/8. The denominator, 5/8. And then I crossed out, and you see that it left me 2 8s in the denominator. Everything left the numerator, so therefore I had to put 1 divided by 8 squared. But we use this method more because, think about it, if this was 8 to the 30th and 8 to the 50th, we would not want to write out 38s and 58s. We would want to subtract. So that's the reason why algebra takes us to this level. Subtract the exponents. 3 minus 5 gave you -2. But you never leave me a negative exponent. Bring it down to the denominator and it becomes 1 over 8 squared. So, let's look at some rules. The negative exponent property. For arithmetic, anytime you have a number raised to a negative exponent, bring it down to the denominator and it becomes positive. If everything leaves the numerator, you must leave me a 1 in the numerator. So for 8 to the -5th, you would rate its final answer is 1 over 8 to the 5th. Let's look at the algebra form. For every non-zero number a and integer n, a to the -n equals 1 divided by a to the nth. 1 divided by a to the nth. So let's look at some examples. Simplifying expressions using the negative exponent property. Topic 3-5, Part 2. Simplify each expression using positive exponents. So we'll always leave our answer with positive exponents. All right, so I'm dividing 2 to the 8th divided by 2 to the 11th. When you're dividing like bases, write down the base and subtract the exponent. So I would subtract 8 minus 11. Punch in your calculator. 8 minus 11, you get 2 to the -3. But you never leave me a negative exponent. So what I must do is bring 2 to the -3 down to the denominator, changing it to 2 to the +3. And everything left the numerator, therefore I have to leave a 1. So my final answer for that problem is 1 divided by 2 to the 3rd. Let's look at our next example. B. 100 b to the 50th divided by 200 b to the 75. With your big numbers, these are your coefficients, your integers, we will just simply reduce them. We can reduce those by dividing each one by 100. 100 divides into 100 one time. 100 divides into 200 two. And then I have b to the 50th divided by b to the 75. Let's subtract those exponents. So I have a 1 in the numerator, a 2 in the denominator, and subtract. I have b 50 minus 75. When you have like bases, subtract the exponents. Therefore, I have b to the 50 minus 75. Punch in your calculator, you get negative 25 over 2. b to the negative 25 over 2. There's really no reason to put my 1 because I have something else in the numerator. Now, b to the negative 5, I cannot leave a negative exponent. Therefore, what I must do is I must bring b to the negative 25 down to the denominator, make it b to the positive 25. And 2 stays in the denominator. It's in the denominator, so it stays there. They're both in the denominator. So if everything leaves the numerator, I must put a 1. The only time you leave me a 1 is if everything leaves the numerator. So let's go over that again. b is in the numerator. b to the negative 25. Bring it down to the denominator. 2 is already in the denominator. It stays. You only move this term. I'm going to circle it. That's the only term you move because it is raised to the negative exponent. So b to the negative 25 came down as b to the positive 25. 2 was already raised to a positive exponent. It stayed. And when everything left the numerator, I had to leave a 1. Continuing with this problem, C part. A to the negative 3, b seventh, c5, divided by a5, b squared, c to the 7th. So, what I want to do with this problem is go ahead and subtract those exponents. So I have a to the negative 3 minus 5, b's, one on top, one on bottom, subtract those exponents, and c's, subtract those exponents. Starting with the numerator first, negative 3 minus 5, 7 minus 2, and 5 minus 7. Use your calculator. Negative 3 minus 5 would be negative 8. B, 7 minus 2 gives me 5. C, 5 minus 7 gives you negative 2. Now that's all over 1. They're all in the numerator. So the terms I need to move are the terms that are raised to a negative exponent. Let's keep b to the 5th on top because it's the only positive. I'm going to move a to the negative 8 down, becomes a to the positive 8. I'm going to move c to the negative 2 down, becomes c to the positive 2. Therefore, my final answer is b to the 5th divided by a to the 8th times c squared. You only leave me one A, you only leave me one B, you only leave me one C. You never leave me two of the same letter in an answer. And you always leave me positive exponents. So raise everything to the positive exponent. Looking at our last example. 2x cubed y to the negative 5, all raised to that higher power of negative 2. Remember from our last section, we take each term individually and raise it to that higher power. This is power to a power. So we're going to raise 2 to the negative 2. You're going to put parentheses around x cubed and raise it to the negative 2. Put parentheses around y to the negative 5 and raise it to the negative 2. You're raising each part to the negative 2. Now, if you multiply exponents, 2 to the first times negative 2 gives you 2 to the negative 2. x3 raised to the higher power of 2. Multiply those exponents. Remember, when one's inside and one's outside, we multiply them. And y, negative 5 times negative 2 is y to the 10th. So right now, this is what I have. I'm going to box it so we can see it. Now, I'm going to go ahead and draw my line because I do need to move some terms. All of this is over 1. All of this is over 1. We never leave a negative exponent. So 2 to the negative 2 comes down as 2 squared. X negative 6 comes down as x to the 6th. But y10 stays. Y10 stays. Now, I'm going to go ahead and expand 2 squared. Because 2 squared, students, is really 4. So my final answer would be y10 over 2 squared is 4, x to the 6th. So in this last step, I simply kept y10. I raised 2 squared because 2 times 2 is 4, and I kept x6. So your final answer is y to the 10th divided by 4, x to the 6th.